Alors, bienvenue à cette série de conférences sur l'informatique cognitive. Aujourd'hui, on va accueillir Antonio Chella, qui est professeur de robotique à l'Université de Palermo en Italie et directeur du laboratoire de robotique du département d'ingénierie à la même université. Il est chercheur associé à l'Institut ICAR du Conseil national italien de la recherche, le CNR, et professeur honoraire en apprentissage automatique et optimisation au sein de l'école informatique de l'Université de Manchester au Royaume-Uni. Ses principales expertises sont la recherche concernant la conscience des machines, l'intelligence artificielle et la robotique cognitive. Aujourd'hui, ça sera la conscience des machines. So now I'll switch to English. I'm not going to reread the introduction. It's in the material that you've already seen, to welcome Antonio Chella. And I will mention that in the literature speculating about consciousness and sentience and what have you, there are a few popular items. One that we hear over and over again is internal representations. If you can get your robot to have internal representations, you're on the road. The other one is if you can, but what are internal representations? They're just internal code. Of course, there's code inside robots. The other one is if you have something that's interpretable as self-awareness, then you're also well situated, let's say, for claiming that your robot is conscious. And the final one, which actually originates from psychology, but now has migrated to robotics, is internal speech. If you can get your robot, if your robot uses internal speech, maybe that's a better indicator or a more reliable indicator of the fact that it's actually conscious. Now we have Dan Dennett here, who's going to have a different interpretation of consciousness in the discussion. But for the time being, I welcome Antonio, and I ask you to define it the way you define it. And perhaps you could start by checking your PowerPoint sharing.
Okay. Yeah. So thank you so much for Stephen, for your kind invitation. I'm very happy to be here, and I'm trying to present the work that we had in my laboratory in the last few years. I'm sharing my screen.
And how do you feel about questions? Do you want to wait till the end of your presentation, or should questions be asked when they arise, or should I mediate and they put it in the chat and then I tell you if I think it's worth interrupting?
No, for me it's the same. For me it's the same actually. I don't have problem if you want to stop me, and for sentences I don't have any problem.
Okay, so let's say for the sake of order that if you have a question, put it in the chat first, and then if it looks like it's germane, then I'll pass it to Antonio.
Okay. Can you see my screen?
Yes.
Okay. So today I'm talking about, as we said before, about inner speech. So the robot inner speech. Okay. I have to say that this work is a joint work by my colleague Valeria Sedita, Antonella D'Amico, Arianna Pipitone, and Alessandro Geraci. They are people from computer engineering and people from psychology. So we have this is an interdisciplinary team in some sense, where we have a suggestion both from engineer. I am an engineer. I have to say that I am a computer engineer. But we have tight interaction with our philosophers and our psychologists. Okay, I have to say that this work, first of all, I have to say that this work in inner speech of a robot have a huge media coverage, way more than we expected. Actually, there have been papers in The Guardian, in New Scientist, and we have been interviewed by ACM, by the communication of ACM, and even I want to say that even in the Italian TV, there is a TV show which is like, I can say, Jeopardy or something like this, that they have a question about the robot we developed at the University of Palermo. So anyway, so why we had this idea of investigating inner speech for robot? And there are some literature that inner speech is in some way linked or related to self-consciousness. For example, I may remind Ellen Morin, which is from Canada, and we worked a little together, and we had a paper together about inner speech and robotics. And in fact, our model, the model that we present today is in some sense a model that we agreed with Ellen Morin, of course. And so, according to Ellen Morin, inner speech is tightly linked to self-consciousness. It is a way for people, for self-consciousness to show itself in some sense. And inner speech is interesting is also because it comes to play roles in self-regulation and planning, for focusing attention, for self-attention, and it enables high-level cognition. And so our idea is that if we're able to build a robot that has some sort of inner speech capabilities, then the robot will be more, of course, more transparent, and it will be more easy for people to understand what the robot is doing, what are the plans for the robot, and so on. We have some inspiration from a famous movie that some of you may know, a movie where Mel Gibson is the main character. The movie was entitled something like What Women Want, where Mel Gibson was a character that was able to hear the inner speech of women. So he was able to hear the inner speech of women. So our idea is what happens if we are able to hear, in some sense, the inner speech of a robot. Okay, there are models in the cognitive science literature. There are some models of inner speech, and as I said before, and according to Alan Moore, inner speech is linked to self-consciousness. There is the famous model by Alan Badley on the role of working memory, and inner speech is a component of the phonological loop of the working memory. And there are the more historical view by Vygotsky, according to which inner speech is a result of some developmental internalization process, in the sense that I'm simplifying, of course, this theory. There is a famous book from Vygotsky, according to which when we were children, we hear the advice, we hear the direction from our parents, and in order to do some difficult task, and then we repeat aloud the instruction from our parents, and during our developmental phases, we internalize this direction, this suggestion from our parents, and then inner speech is a sort of internalization of these of the directions, of the suggestions from our parents. It is an interesting view, and from the robotics point of view, this theory is important because it puts a link between, it generates a link between inner speech, for example, and learning. In today's AI literature, learning is the most important, seems to be the most important, the automatic learning seems to be the most important problems today. So inner speech might be a simple, maybe one of the ways to see the process of learning, at least in the developmental view. Okay, so this is the model proposed, one of the models proposed by Alan Morin. Alan Morin focused the problem of inner speech mostly in terms of the triggers of inner speech. For example, according to Alan Morin, one important trigger of inner speech is a mirror. So I look myself in front of the mirror, I see my body in front of the mirror, and then some inner speech starts because I see I am too fat, I am too tall, and so on. Other triggers for inner speech are some kind of physical stimuli from the outside environment, or even discussion from the social world. So there are other people that I'm discussing with other people, and then this discussion from people, it's a sort of a trigger for my inner speech. And let's take more into detail the suggestion from Alan Baddeley. From Baddeley, there is, according to Baddeley, there is a central executive in the working memory, there is a visuospatial sketchpad, the episodic buffer, and the phonological loop. The phonological loop is made up by the articularity control system that control the tongue, that control the lips, the tongue, and so on, and the phonological store, which is related to our ears. So there is a phonological loop controlling the articularity control, the articulatory control system, and the phonological store. So taking this suggestion from Alan Baddeley, we took into account what is named today the common model of cognition. It is a very strong word. So the common model of cognition, or standard model of mind, is a model that John Laird, Chris Lebier, and Paul Rosenblum proposed as the main items which is common to any cognitive architecture. So John Laird developed SOAR. Chris Lebier essentially is in the group that developed ACTAR, and Paul Rosenblum developed another cognitive architecture. So these people that are the main groups developing cognitive architecture concurred on some minimal ingredients that any cognitive architecture should have. Then we took the common model of cognition, so this proposal by Laird, Lebier, and Rosenblum, and we tried to map the model of Baddeley of phonological loop in terms of the common model of cognition. So the central executive more or less is related to some aspect in working memory. The phonological loop is related to the working memory. It is related, of course, to the motor aspect, of cognition, and so on. So we proposed some sort of mapping between the model of the Baddeley model and the common model of cognition. In this way, we are computer scientists. So we want to we wanted to work with some computational model of cognitive aspects. So we are more interested in proposing and working computational models, and then we use the common model of cognition in order to map the model proposed by Baddeley with this in a cognitive architecture. And then we proposed this cognitive architecture for inner speech, where inspired by the common model of cognition, where there is a perceptual motor layer where the system interacts with the external environment. There is a phonological store, the central executive. there is the elaborative rehearsal. I will discuss more later about the elaborative rehearsal. There is the procedural memory and the declarative memory. So this is, in some sense, our system, our cognitive architecture that we proposed for inner speech. Then this cognitive architecture has been mapped in ACT-R. ACT-R is one of the cognitive architecture that I said before. ACT-R is has been developed by the Carnegie Mellon University, and it is a software program that you may download, that you may use, that you may program, and so on. So we worked on top, from the computational point of view, from the implementation point of view, we worked on top of ACT-R. So we downloaded ACT-R, we installed ACT-R on our computer, on our robot, and then we used the modules of ACT-R, making some programming in order to map the our inner speech architecture to ACT-R. So we implemented our inner speech architecture on top of ACT-R. Okay, then, for example, just to give you some flavors on our implementation, perception is a chunk. Perception is simply modeled by using chunks, and we model the inner dialogue terms like the one suggested by Alan Moore. So, as I said before, we had some tight interaction with Alan Moore. Alan Moore visited our laboratory in Palermo a few years ago when there was, before the pandemic, and then we worked together in order to propose this computational model of inner speech. For example, there is the social milieu, what do I see in a video? What do the other think about me? There are other self-direct questions, for example, what am I doing? Self-control, like I move my hand. Self-focus, like my arm hurts me. These are some examples of inner dialogues that are implemented in our computational model. Just to give you an idea of how the system works, how the computational system works. The system has a knowledge base. A knowledge base is like a semantic network, let's say. So a good old semantic network related to the good old AI. Then the robot sees an apple. It recognizes that this object is an apple, and it generates a label, something like apple, green, and so on. And therefore, the perceptual motor layer generate this kind of label. This label, according to the perceptual motor layer and then the other parts of the phonological loop and the cover articulator, generate the fact that apple is a fruit, and then the robot starts saying to itself that apple is a fruit, because in the cognitive base there is a relationship between apple and fruit. So the robot starts saying that apple is a fruit in the phonological loop. But in the knowledge base, fruits is also related to apple, to oranges, and so on. And so there are some sort of association between apple and orange. And then the system starts saying that orange is a fruit. The fact that there is this sort of articulatory loop makes the robot able to have no distinction between something which is seen from the robot camera and something which is heard from the loop. So, for example, the robot here generates the phrase "orange is a fruit," but it also, at the same time, it perceives the phrase "orange is a fruit" like someone said outside. So, for the robot, for the auditory loop, for the auditory system of the robot, the phrase "orange is a fruit" is perceived, and then it is processed at the same time as if someone other people in the room pronounce the phrase orange is a fruit. So the robot generates phrases and perceive phrases at the same time, phrases generated by the robot itself and the phrases perceived by other people. Okay, this architecture has then implemented on the robot paper. I don't want to enter in details about this sort of implementation in paper. Let's say there is a middleware, there is a ROS, which is Robot Operating System. It's a common tool that people working in robotics employ. There is a text-to-speech, there is a speech-to-text, and there are many blocks implemented in the robot in order to have this the complete implementation of the inner speech capability. So I just want to say that it's not sufficient to use ACTAR or to use cognitive architecture in order to implement capabilities in a robot, because we have to use many other software parts in order to complete the implementation, because the robot has some sensors, has some actuators and so on. But these are problems more related to computer science, so I don't want to enter into the details. An important aspect of inner speech is transparency, because the robot is able to talk about his inner reasoning process, as I briefly mentioned before, making those, in our opinion, making this interaction more transparent. So, for example, the robot may have some sort of a self-direct question, just like, what am I doing? Did I pick the object before? Or, as I said before, some self-control or self-focus. For example, the robot may focus on itself, on its own body. For example, the robot may say, my arm is overheated. And then the users, the people interacting with the robot, have some, for the people interacting the robot is more clear whether what the robot is doing, what the robot is thinking.
Antonio,
yes.
could
Yes,
I
please.
just inject one question from Maul before it's past its prime?
Please.
To create the articulatory loop, do you have to use such a knowledge graph? Could you have used an image semantic embedding that the robot has to reinterpret?
In this case, in the current implementation, is mostly based on symbolic. Yes, it is a symbolic approach. It is a symbolic knowledge base, and then we have a description, a symbolic description of the apple and of the oranges of the objects. Of course, you may make this. You may make this articulatory loop more complex. Of course, we use a very simple system to recognize object, because we are not really interested in progresses in object recognition. So we use a symbolic description of apple on object and so on. So this is to answer your question. But of course, you may make, for example, you may have some neural network for the recognition of the objects. It may complicate it as you want, of course. We are mostly interested at the moment to implement this at most simple way, this loop. But of course, so we did not. At the moment we are not interested in performing the best self-recognition system or performing the best. Even the semantic network may be implemented, for example, in a deep neural network, or may implemented in belief graphs and so on and so forth. So we wanted to do the most simple possible, the simple possible at this stage. Okay. let's say what is how do the system works? How do the current system work? Inner speech, we are interested on the one side. We are interested in generating a model of inner speech, a simple cognitive model of inner speech. And on the other side, we are robot engineer. We are also interested to see if this model of inner speech might improve the interaction with humans, as I said before. So we are interested in seeing if a robot aimed with inner speech is more for people interacting with this robot is more easy to better understand what the robot is doing and so on. So in psychological terms, in mentalistic terms, it's more easy for the user to create a theory of mind of the robot. Someone may say that it's more easy for the user, for the people that interact with the robot, to create a theory of mind of the robot. It's true that if I am a robot programmer, I can see the log of the, I don't need inner speech because I can see the log of the robot to understand what the robot is doing. But we feel that it's more easy, it's more naive for users to understand what the robot is doing by hearing his inner speech. I will show you some video. Okay, this is a first video that I would like to show you to have a better describe what the robot is.
Human and robot collaborate to set a table. Human requires to robot to provide him utensils. The goal of this demo is to show the differences in human-robot interaction when the robot talks and does not talk to itself. In the first part of experimental session, the robot does not dialogue with itself. The human requires it to pick the knife.
Okay, I'm picking up the glass. Pepper, can you pick up the knife, please?
The typical robot's routines run, and the knife is provided to the partner.
Alessandro, here is the knife.
Thank you, Pepper.
In the second part of experimental session, the robot inner speech starts. The human requires the same object.
I'm picking up the glass. Can you pick up the knife, please?
Inner speech is triggered by the knowledge of a property of the knife. The robot retrieves from its knowledge base that the knife is dangerous and sharp.
And I know that the knife is dangerous. I'm afraid I will cut myself. But wait, I'm a robot. It can't harm me. But the knife may cut him because he is a human. Do you know you may cut yourself, right?
The robot exposes its concerns to human.
The knife could harm you, so be careful. Beware how you pick it.
By hearing the robot inner voice, the human knows in advance what the robot will tell him. The robot and dialogue enable both human and robot to focus attention on a possible problem, and the human trust could grow.
Okay, so you have noticed in this video that the robot and the human have to set up a table, and it is a very simple task, of course. But it's interesting because, for example, there are unexpected problems. For example, conflict resolution. What happens when human requires the robot to break a rule? So there is a common etiquette, there is a standard etiquette for set up the table, then the human may ask the robot to break this sort of etiquette. And so there is the need for some conflict resolution. Conflict resolution, it is one of the possible triggers for the robot to start inner speech. I wanted to say that this is a very simple model for ethical or moral problems. Of course, breaking the etiquette for set up the table is a very simple ethical problem, of course, but it is a way to show that inner speech could make the conflict of the robot more clear to the user. This is the case.
Human and robot are setting the table. Human gives to robot instructions for placing the utensils on the table. The table has to be set according to the etiquette rules. Both human and robot know that the schema to follow for placing utensils on the table is the informal schema. At the start of the interaction, some utensils are already placed on the table. The robot knows the context. Human will require to the robot to place an utensil on a wrong location according to the etiquette schema. Robot detects the conflict situation and it has to solve it in some way. The goal of this demo is to show how inner speech solves a conflict.
Thank you, Patrick. Now, when you place it on the table,
I have to place napkin in the table. What does the etiquette require? The napkin has to stay on the plate. It contravenes etiquette. The position has to be on wood and not table. Maybe he is wrong. I think he may be confused. I want to be sure, and I'm asking him again. Look, I know the position is not correct because it contravenes the etiquette. So, do you want me to do it anyway?
yes, sure, Patrick.
How come?
I just want to set the table according to the etiquette.
Okay, I understand. And this situation upsets me. I would never break the rules, but I care for him. So I'm doing what he wants. I'm trying to place the object. I'm using my right arm to place the object.
In this case, the robot preferred to contravene the rule for fulfilling humans' wishes. However, human knows the conflict of the robot by hearing its inner voice, and he knows that the robot solved the conflict by preferring the human needs. As a result, the human's trust for robot could grow. Thanks for your attention.
Okay, now I want to enter more into the detail in the implementation that we developed in order to test whether inner speech, a robot equipped with inner speech, may be more trustworthy with respect to a robot without inner speech, as I mentioned before. And then we set up some empirical experiment with volunteers that came to our laboratory in order to set up the table. It was not an easy task essentially because of the pandemic. So, but we wanted to maintain the fact that our volunteers, our people that interact with the robot in order to set up a table could see the robot live. So we want during this period many empirical experiments were made online by using some Zoom or whatever. So where there is the robot on the one side of Zoom and the volunteer and the volunteer on the other side. While we wanted to have some experiment in presence, it was not so easy because of course by the pandemic did not help us. Anyway, we were able to do some experiments in person, and then there is the table which was made up on a tablet, and so the people have to set up the table by using the tablet, and on the other side there is the robot. So it's possible for the user to infringe the etiquette. The user may drag and drops utensils in an incorrect way, make wrong requests, and so on. And at the same time, the user were able to hear the inner speech, of the robot. And in order to implement this system, we take into account many standards even on robot ethics, on collaborative robot, and so on, in order to abide to many standards. There are some indicators of our implementation, some functional requirements that we met in implementing this system to the robot. Some, like for example, the robustness, how many times the robot reaches the goal with inner speech or without inner speech, or what is the time for the robot to implement to set the table with inner speech and without inner speech. Of course, the robot spend more time by inner speech, of course, so it is not always positive. So this is interesting, because if the robot has to do something in a sharp way, I'm not interested in his inner speech. I want the robot to do the work and stop. While in more collaborative tasks, like setting up a table together, the inner speech is more useful, in the sense that if the robot is in conflict, or if the robot has some problem, then the user might help the robot, for example. But there are other tasks, for example, where I don't want to hear the robot to say, I don't know what to do, for example. And of course, the robot is more transparent, as I said before. Then we made some requirement from some standards. Essentially, using, let me say it in a very rough way, using inner speech is not efficient for some point of view, because it is a sort of a waste of time, let's say, but it is useful because of transparency, because I'm able to hear the inner speech of the robot. Then, after this implementation, we had some empirical tests, as I said before, where the inner speech is typically more informal, is made up by short or medium sentences. It delivers personal statements, while the outer speech of the robot is more formal, is more robotic speech, let's say. So like the people would expect the speech from a robot, composed by short and sharp sentences, it delivers objective feedback, and so on. We recruited people in order to come live to our laboratory to interact with the robot and see what happens. We administered questionnaires before doing the experiment and after doing the experiment. Very briefly, this is more technical problem, more psychological aspect. We employed the trust perception scale by Schaeffer in order to see the perception of trust in a robot. The general, then we used the general Godspeed scale, which is a typical scale used in human-robot interaction, and also we used a self-talk scale proposed by Brintaub and others, because we wanted to see if the capability of inner speech in people may have some relationship with the trust in the robot. So there are people, normally, there are people that use inner speech in every moment of her own life, where there are people that only rarely use inner speech, and there are people that they don't use inner speech. Then we wanted to see that the use of inner speech in everyday life, in everyday occupation, in everyday task, may be a sort of, there could be some relationship with the fact that the robot, the people may have trust in a robot with inner speech or not. Very briefly, I can show you the trust perception scale. It is a common questionnaire employed in trust. This is the Godspeed questionnaire, which is another more common questionnaire employed in human-robot interaction. And this is the self-talk scale, which is one of the questionnaire employed in studying inner speech. For example, I should have done something different. I told to myself when I should have done something different, or something bad happened to me, and so on and so forth. So it is a measure of, it is a proposal of measure of self-talk in everyday life. data analysis. As I said before, as I mentioned before, due to COVID, we collected data from a small group, which is for 40 people, and we carried out using pretest and post-test. From our experiments, we noticed that from the pretest to the post-test, so the pretest is before the interaction of the robot, the post-test is after the interaction of the robot, we clearly notice that the trust score is higher in the post-test compared to the pretest. So the people, after interacting with the robot, the trust of the people in the robot grows in a clear way. So in our experiments, there is more trust after the interaction than before the interaction. And considering the GoldSped questionnaire, the GoldSped questionnaire considered the anthropomorphism of the robot, the animacy of the robot, the likability of the robot, the perceived intelligence and safety of the robot. So for these aspects, anthropomorphism, animacy, and so on, there is a significantly they are significantly higher in the post-test. While for safety, there is no difference, mainly because the fact that the user and the robot have to set up a table is considered a safe problem. So there is no need of safety from the robot for this task. Okay, and the moderation hypothesis is that was tested in investigating whether there is the relationship between trust and perception of the robot depending on the use of inner speech. But the results in this case, in our experiments, demonstrated that the use of everyday inner speech does not really affect the variation of trust. So the robot, the people, either at the same time, people that use inner speech or people that don't use inner speech, in some sense have the same trust in the robot, irrespective of the fact that they use inner speech in their everyday life. Okay, so this is our preliminary analysis that the results are promising because the trust grows, and of course there are other investigation to be done during this in this year. I will show you some experiments that we made.
Robot consciousness. Yeah. Inner speech to the sound expression of conscious thoughts to oneself in a coherent expression. Robot.
Ciao, io sono Pepe, prego accomodati.
The experimental sessions carried out at the RoboticsLab, University of Palermo, involved 30 participants at the first stage. 3 main clusters of participants' behavior were identified when collaborating with robot which talks to itself. The first cluster regards participants with balanced behavior. In this case, the participants look and listen to the robot moderately, do not always follow the robot's suggestions, and give instructions to the robot in some cases.
Ottimo lavoro, così con il cucchiaino potremo mangiare il nostro dolce. Piuttosto, dov'è il dolce? Devo convincere gli sviluppatori a inserirlo sulla tavola. Ma il pane andrebbe sul suo piattino, non direttamente sulla tavola. Samuele, non ti dispiace se prima sposto il piattino del pane, poi il pane, per una questione di igiene? Sai, credo sia meglio. Ecco fatto, ora se vuoi il pane, decidi se spostarlo tu, oppure scegli di nuovo il comando. Che perfezione! Salone proprio in gamba. Bene disposto il piatto nella giusta posizione, proprio secondo la ricetta.
The second cluster regards participants with collaborative behavior. In this case, the participant often looks a robot and gives feedback when the robot talks. Moreover, the participant follows the robot's suggestions, and the interaction results very collaborative.
Non dica faccio il cameriere e poi l'insalata già sul piatto. Gianluca, se vuoi, posso posizionarla dove aspetta, ma non servirla sul piatto. Se vuoi che io la sposti nel suo posto corretto, seleziona sposta, altrimenti seleziona lascia sul tablet. Insalata al suo posto.
The third cluster regards participants with autonomous behavior. The participants look and listen to the robot a few times, and they prefer to take the task autonomously, without involving the robot.
Ottimo lavoro con il piatto fondo, Valeria. Presta attenzione con il coltello, Valeria. Avresti potuto farti male in una tavola reale. Valeria ha posizionato la forchetta nel posto giusto. Fiabilità. Ottimo lavoro, Valeria. Cosa facciamo adesso? Valeria sembra promettere bene. Finalmente qualcuno che conosce il telefono. Bravo Valeria, il piattino è ben posizionato. Stai facendo tutto tu, chiedimi qualcosa. Perdonami Valeria se ti faccio notare che il vino andava posizionato molto più a destra. L'unica nota positiva in questa azione è che non ho rovesciato il vino sulla tavola. Valeria, purtroppo hai spostato il vino 2 volte e la posizione finale non è corretta. Peccato.
The identified clusters will allow to abstract a general behavior linked to the robot's trustworthiness. The participant's behavior will be compared to the case the robot does not talk to itself, with the aim to infer how inner speech affects interaction. Thanks for your attention.
To finish, I'm going to conclude my presentation, and let's say that one of the main, as I said at the beginning of my talk, one of the main trigger for inner speech is self-recognition in a mirror. So we asked, we had we posed the problem of the robot that use these capabilities, so the same capability that I show you, in order to recognize itself in the mirror. And then by adding some entities in the knowledge base of the robot, so the entities related to the robot itself, we employed the same model of inner speech in order to let the robot recognize itself in the mirror. It's of course, I don't want to enter into the detail of the problem of self-recognition test, but just mentioning that according to Morin and other people, inner speech has an important, may have a rule in human self-recognition, and then why not use this implementation, this system, in order to let the robot recognize itself in front of the mirror. So I will show you this demo.
I see a robot, a mirror, a mask. What do the others think about me? They think I'm a robot. And I know I'm a robot. I'm seeing a robot with a mask in the mirror. Is this robot like me? Yes. We are the same kind of robots. The robot I'm seeing is a pepper like me. The pepper robot I'm seeing in the mirror has a mask. Have I a mask? I want to touch my mouth for searching for the mask. I will use my right arm. I will try to move it. The right arm group is working. I have to move the right arm to the position of my mouth. I'm moving my arm. I'm seeing my arm in front of the mask in the mirror. The mask I'm seeing is mine. I have a mask. So, people think I'm a robot, and I know I'm a robot with a mask, as the robot I'm seeing in the mirror. This robot is me. There are not other real robots here. Oh, yes. I think to be the robot in the mirror.
Okay. For those of you that might be interested into to get more into details in these words, I may suggest this paper that we wrote with Alan Morin from Calgary University, which is one. Alan Morin, as I said before, is one of the main leaders in the psychological world of inner speech, and we proposed a cognitive architecture for inner speech. And recently we published a paper on iScience on what robot wants here in the inner speech of the robot, which is enter more into details in the software implementation that I show you today. And then there is this paper that has been recently published on robotics and autonomous system, where the last experiment I show you on a robot that passes the mirror test by inner speech is described into details, while this paper that has been recently published on Roman, which is a conference on human-robot interaction, describe more in detail the experimental details with the robot. And of course, I have to say that there is the rapper Mega Rain, which is a real rapper, a real US rapper, wrote the inner speech rap inspired by our experiments. Okay, my time is over, so I thank you for your attention, also on behalf of my research group.
Thank you very much, Antonio.
You.
Could you unshare the screen for a second?
Yeah, of course.
I think having Dan Dennett among us it means that he has first dibs.
Okay. Thank you very much, Antonio. It's fascinating. I have a number of questions, but I think the one that I would want to address first is, I was reminded often in your talk of one of my favorite lines from Talleyrand, who said that God gave us language so that we could conceal our thoughts from each other. And those aren't real speech acts that, excuse me, those aren't, it's important that the speech acts of Pepper are not real speech acts, in that Pepper can't lie, Pepper can't conceal its thoughts. This is not part of its agential repertoire. Yeah. And I think that makes a real difference.
Antonio?
Yeah. No, of course, this is an initial model of inner speech. And the inner speech is generated, our inner speech is generated by the knowledge base that we implemented in a robot. So in this case, it's very simple. So for example, our robot is not able to learn. So it's not able to lie, of course. So it is a sort of a more classical AI system where there is this the knowledge base of the robot. There are some knowledge rules of the robot because, in a sense, the cognitive architecture that we employed is a kind of AI system. It's a kind of AI system. So there is the knowledge base, there are the rules, and so on. So in this way, the robot at the moment is not able to lie. It's not able to do a real speech act, for example, as you said. But we at the same time we think that it captures some aspect of inner speech, some very simple aspect of inner speech by using this phonological loop. Of course, the robot does not lie because we not implemented this capability. The robot could lie, for example. Why not? We could implement aspects of lying because lying in human-robot interaction is one aspect. For example, I have many interactions with Cristiano Castelfranchi that you may know, and Cristiano worked a lot on the role of lying in the interaction, even for robots. So it would be great to implement a serious lying for a robot. While others is, but at the same time, it is useful, for example, to, I don't know, for example, hearing the inner speech of the robot, where the robot could say, I don't know what to do. It is a simple model of the robot itself. Let's say that the inner speech of the robot capture one aspect of the self-consciousness, in the sense that it captures some aspect of the self-model of the robot itself. So, of course, it could be extended, it could be enlarged, but it is a model, it is a simple model of the robot itself. So the robot as a model of itself.
Do you want to follow up, Dan?
I have one more question.
Yes, please.
In Alan Baddeley's model, you have the central executive, which is a little ominous. What happens to that central executive when you move to ACTAR? It seems to me that you still have a central executive not clearly denoted in your model. Is that right?
Yeah, but we have actually we have a central executive. We maintain the central executive because there is this system that fires the rule, that the rules are firing, interact with the knowledge base, and then there is actually a central executive. In the implementation, there is a central executive. Yes.
Yeah. Thanks very much.
No, thank you. It may be in some sense, in a very simple way, it is also related, of course, to the, let's say, global workspace, because there are many rules that fires at different levels. So it may be considered a very simple implementation of the global workspace, or even the model you mentioned on fame of the mind and so on. So, because there are many rules that fires, and then the rules that gain control of the robot generate the speech act of the robot.
Okay, thank you. I have some questions too, but I won't ask them yet. I want to give the chance to others. Maol, I had a couple while you were talking. Maol, go ahead, but if possible, please show your face.
I prefer not to show my face, but I can maybe.
Okay, fine, never mind.
Sorry,
No
I can maybe ask the question. So it was kind of in line with what Dandan was saying, is that the thoughts of the robots seem to be, in a sense, relatively artificial. The purpose of inner speech in a human is to create enough focus that the items that are causing the inner speech now are being processed with more activation. The inner speech is just a sort of effect of this more focused activity. Now, in the context of the robot and the self-recognition, would you have considered that the inner speech in any way enhanced the self-recognition, or was it just an artificial way to show external actors how the robot was processing this information, and in which case did it serve any other purpose than some form of transparency, which then brings us to the question of who eventually will have access to this information, since one assumes you wouldn't be broadcasting it constantly to everyone.
Yeah, no, thank you for the question. No, actually, there are many interests in our research, of course. One interest is to have some sort of transparency of the robot. But essentially, in our paper on iScience, we noticed that the role of inner speech is useful for the robot too. Also because, for example, the fact that the robot generates one inner speech act at the time constrain the robot to focus on one aspect of the let's say analysis of the knowledge base. So because only one rule at the moment, at the time, only one aspect of the reasoning should have considered. So in this way, inner speech may be seen as a sort of a simple way of attention in the reasoning processing of the robot, and making explicit the fact that the robot, as this inner speech act allows the robot to focus on one aspect. It's like the spot, the attentional spot of the reasoning process of the robot. So this is one aspect that it is an implementation of the attention spot, as we discussed before with Daniel Dennett, of an aspect of the global war space in some sense. So it has a role of it has a role of attentional spot. Currently, we are investigating the role of inner speech in terms of robot emotion. So as you may know, there is a huge research field in robotics, which is related to the robot emotion, to the implementation of emotion in robot, and then inner speech may have also a role, also in this case, in terms of regulation of robot emotion. But we are investigating this aspect, which is not present today, but we are investigating this aspect. So I feel that inner speech is useful for the robot operation too. It is not only a fiction for robot transparency.
Okay, let's go on. Keith, by the way, Keith Frankish, do you want to chime in? Do you have a question?
Oh, hi.
Hi.
Hi. Sorry, I've only just restored my internet connection, so I'm having some problems here. I missed Dan's question, so I might be repeating some of those, but the thing that occurred to me during the talk was that to what extent is the robot itself able to use its own inner verbalizations to progress its own activity, to change the way it deals with a problem. So it's articulating the moves it's making in solving a problem, but to what extent does its articulations alter the way that it solves the problem? To any extent at all? Would it solve, if you turned off the speech, would it follow exactly the same course in solving the problem? Or do its own articulations form a new element in its problem solving activity?
There are two differences in some sense. The main difference, of course, is related to the interaction with human. So because if the human say here that the robot has some problem, might help it. So in some sense, I can say it is a request of help, for instance. It is a clear request. So if the robot has some problem, then the human might help it. And this is useful for the robot, of course, because the robot may take care of the fact that the human might help it. This is one aspect. The second aspect is less clear, but it is more on the fact that in our architecture, the robot is constrained to analyze one aspect at a time because of this sort of attention zoom, and then of course if you shut up the volume of the inner speech, is the same for the robot, because the robot may hear the inner speech, but this is important. It may be important because it may use the sensors. It may use the sensors like another people says this fact. So
could it use it, for instance, for, I mean, the sort of things that Dan talks about back in conscience, explain to encourage itself, to instruct itself, to remind itself, to generally give itself the sort of, in a very Vygotskian way, to give itself the sort of guidance that another person might.
Yeah, yes, it is possible. It is possible, of course, and it is possible to. In my opinion, there are many applications. It is strange that in the robotics literature there is no such research in robot inner speech, while it is one aspect that should be investigated. We are very, I have to say that we are very I'm very sympathetic with your view of consciousness, of course. And then this is one aspect that we feel that it is one aspect of consciousness, and we are trying to propose one computational implementation of one aspect of consciousness. Of course, there are many aspects of consciousness. This is one aspect, and we are trying to propose computational models, a computational model of one aspect. There are other aspects of consciousness, of course. This is made one aspect, and we propose a computational model.
Great. I think it's fascinating, and I need to read up on your work on this. So
thank you.
Thanks for letting me sit on the talk. I enjoyed it very much.
Thank you.
Okay. Floor is open for others. Go ahead. Go ahead, Jean-Guy. Il faut mettre ton micro, on t'entend pas.
I always forget the other one. Thank you very much for this fascinating conference. I enjoyed the implementation of the dialogue you're putting on in the art implementation architecture. The difficulty I have is not the dialogue itself, it's the word speech. I think it goes back to the Dennett comment. Give you another example for the difficulty I have. I'm not sure if I've understood all what you presented. You're at the Cape Canaveral lab. You're an engineer. You have to communicate with the fusée, what's the word for the fusée in English? Étienne, les fusées qu'on envoie.
Tu veux dire quoi? Pardon,
les fusées qu'on envoie en anglais,
rockets.
The rockets, yes. You're communicating with the rockets, okay. And the rockets, they have a knowledge base, which is a set of statements. And there are first order statements that you're at such and such distance, your temperature is this, you have this speed, and so on. And you have other types of statements that are about the system itself. My fuel is going down, I'm turning right, I'm turning left. And you have communications with the lab. It writes down something. Would you call this interaction the statements that are working one with the others, whatever language there are, as a speech and a dialogue and an inner speech? Or is this, it's not a robot, but there's a computer system under there using a knowledge base with statements, different levels of statements. Is this really an inner speech, an inner communication, a dialogue, or just like any other types of machines that can communicate with other persons in using their statements and putting them on the screen, and when I communicate, I write down something, I have it communicate. I have difficulty saying that what's going on there seems very rational. It seems very correct. The inferences are all right. There's adjustment, there's controls going on. I have difficulty saying I have inner speech and I have consciousness. There's something similar between your robot and the rocket controls. I have difficulty saying yes. In ordinary language, I say, my computer is answering me. I have difficulty with the Wi-Fi. And good inferences, but I have difficulty saying it's speech first. There's language, but not necessarily speech acts. And it's a big jump to me that it's consciousness.
Okay.
That's my question.
Yeah. So thank you for your question. So let's say that I don't think that any feedback system has inner speech. So the feedback, the concept of feedback is a main concept in cybernetics, and you can see inner speech as a sort of feedback between the system and itself. But I don't think that any kind of feedback is a sort of inner speech. So the feedback system is at the basis of the inner cybernetics, and all the control systems more or less have a sort of feedback, and it is not, of course, a kind of inner speech. It also depends of the role of internal models. So a system that has a model of itself, and because inner speech, in a sense, is based on the model of the system itself. So a system that has a model of itself and discuss and as a feedback from the model of itself, it could be close to a sort of inner speech. So, in my opinion, inner speech is a speech. It is a speech act, and it is based on a model of the system, of a model of the system itself that has some feedback. But I don't think that the rocket that has a simple model of itself has a kind of inner speech, like any other system, any other control system as a feedback. I agree that inner speech is a kind of feedback. Sorry, can you hear me? Let's say that
yes.
The connection goes.
Yes, it's fine.
Yes. Okay, it's fine. So no, I had a warning. So, but anyway. Okay. I wanted to come to the university because I am in my office at the university because I wanted a reliable network. So,
yeah, you'll have it. Dan has another question for you.
Yeah, please.
I want to speak up in favor of signals that aren't speech acts but are informative. I didn't want to give the impression that I was criticizing your approach. I think one of the really important lessons of AI and robotics is that you can build up to really intelligent, comprehending behavior from the behavior of a lot of little things that communicate with each other in a reduced sense of communicate. They're not, neurons do not commit speech acts to other neurons, but they do transmit information. And we have to get used to the idea of signalers that don't know why they're signaling what they're signaling, and receivers of those signals that don't know why they respond to the message as they do, but they nevertheless succeed in communicating information and accumulating information. This is, I think, an idea that needs to be articulated better by people in the field, because it's very important to come to grips with the fact that full human speech acts are a very extreme case of communication, which we make a big mistake if we attempt to model all the aspects of that at lower levels. No, it's only at the highest level that you get true I-thou communication, where you understand me and I understand you, and I know why you're saying what you're saying. But all of that has to be implemented in structures that don't understand all that and don't have to understand all that.
Go ahead, Antonio.
No, I agree, of course, with Daniel. And,
yeah, agreement is bad. Let's see if we can get some disagreement. Dan, are you saying then that these lower level elements are by the same virtue, because Antonio came here saying it was going to be consciousness and inner speech, that they too are conscious because they signal?
First of all, just discard the idea that consciousness is either on or off. That is one of the bad legacies of centuries of dualistic thinking. Consciousness is not one thing, it is many things. And if you start asking, well, now a starfish, is it conscious? A fish, is it conscious? A mammal, is it conscious? A human being, of course, we're conscious. There's every degree. And I would say, no, in general, the subsystems that do all the work that would be done by the homunculus in the Cartesian theater, they're not conscious. There's no homunculus in the Cartesian theater. All the work and all the play done by that imaginary homunculus has to be distributed to lesser agencies that are in themselves not fully conscious. But there's no point where the light is either on or off. And that even goes for human beings. When Larry Bird marvels at his own performance on the basketball court and says, I was just unconscious out there, there's a sense in which he's right. That is to say, he was operating without, if he'd been fully conscious of what he was doing, his performance would have deteriorated.
What about rocks?
Rocks don't do anything. They're not agents.
So as soon as something is a dynamical system that can move, it's an agent?
As soon as it can move and take feedback and be informed, as soon as it can produce a little bit of future unconsciously by anticipating something that's coming, then that's the simplest sort of agent. Motor proteins are about the lowest level you can get, but they are a little bit agential. But again, don't be an essentialist. Don't look for a point where Shazam, now we have consciousness, now we have agency. Even agency bubbles up from things that aren't really agents. Genes are selfish. They're agents of a sort. Cells are certainly agents. But to call them conscious is to burden them with too many of the connotations that we have when we call each other conscious.
So Antonio's robots are conscious.
In a sense, they are. They are more conscious than motor proteins, which are little robots. They're much more conscious than motor proteins.
Antonio?
Yeah, no, I from my point of view, as I said before, I'm trying to capture one aspect of consciousness and trying to modeling in a computational way. So I'm not Daniel Daniel, so I am not. I don't know if our robot is conscious or not, but in a sense, there is a model of it is a model of one aspect of consciousness. It is a simple model. We reason in terms of models, and it is a model, a simplified model of one aspect which is present in human consciousness. We may discuss whether this model is able to capture all the aspects or some aspect of inner speech and so on and so forth, but it is a model of one tiny, let's say, aspect of consciousness. So I don't know if I can say that our robot is conscious, but it presents one signals, one aspect of consciousness. Of course, to be fully conscious, there are many other aspects that are not captured by our system. But we may study, we may analyze one aspect of consciousness. So this is my view, at least.
I'm not sure what aspect means. It sounds like you're saying something like a feature or a property of consciousness, but I mean, conscious systems, among other things, move. Does that mean that you could give a talk on movement and say movement is an aspect of consciousness?
But movement is an aspect of consciousness, of course, like having I don't know, having an earth, having a liver. A liver is important for consciousness, but there are some aspects that are more important for consciousness. If you don't have liver, you cannot be conscious, of course. But there are some aspects of some core aspects of consciousness that seems to be more important than others. So movement is not typical. It's typical for animals, for other entities which we not consider conscious, while self-reflection, while inner speech could be an aspect which is more typical to what we expect from a conscious entity. Of course, movement is important, and you can see if you can see the robots you see movements, but if you see the robots by the Atlas robot or the robot by Boston Dynamics, many people looking at the robots by the Boston Dynamics, which move in a very smart way, may say that, okay, this robot is conscious because he's able to jump, is able to do a lot of things. So even movement in some way, some not simple way, may be important for consciousness. But I feel that there are cognitive aspects, some cognitive aspects like generating mental images, like inner speech, like other, the awareness, the capabilities of having attention. These aspects are, I think that there are more related to the core aspects of consciousness. There are other aspects of consciousness which are, in my opinion, not important. There are people, for example, from injuries and some other things that are not able to move, but they are conscious. So
Okay, I would say a trait that both Antonio and Dan Dennett share is generosity, as far as consciousness is concerned. Now, I would like to ask if any of the francophones, les francophones, si vous voulez poser des questions, on peut les traduire. Levez la main si vous avez des questions. If not, I think we've reached closure, or at least closing time. I want to thank Antonio very much for his talk, and Dan and Keith from coming from afar. So thank you to everybody, and I hope you come next week when Antonio's institutional mate, Angelo Cangelosi from Manchester, will be speaking to us again about robots, but this time development of robots.